So for number two, a spring of natural length 1.5 centimeter. So we have a spring of natural length. So let's say this is the spring. So the length of this spring is 1.5 centimeter. Is extended by 0.02 centimeter by a force of 1.5 Newton. So if this length is extended, like if you apply a load, so it will extend by 0.02. So let's say from there to there. So if I apply a load of 1.5 Newton, so that is a spring of natural length 1.5 centimeter is extended by 0.02 centimeter by a force of 1.5 Newton. So meaning if you attach a block of 1.5 Newton here, then this spring will stretch by this. So that means this 0.02 is the extension. So I know the extension now. Let's say E1 is equals to 0.02 centimeter. Because the answer is in centimeters, so I don't need to convert. Now what will be the length, or what will the length be when the applied force is 4 Newton? Now what if instead of stretching it by 1.5, let's say you stretch it by 4 Newton. So if you stretch the spring by 4 Newton, so what will be the length? Now according to the question, now we have E1 to be 0.02. is stretched by a force of, so that is F1 equals 1.5 Newton. Meaning if you apply a force of 1.5, this string is stretched by 0.02. Now if you now apply a force of 4 Newton, so F2, then what is the extension? Yeah, so if we know the extension, then we can know the new length if you extend it by 4 Newton. So remember from this diagram, so I'll just change this diagram. Yeah, so now the relationship between the force and the extension is F is equals to KE. So this is from Hooke's law. So F equals KE, and we know that K is equals to F over E. So meaning that F over E is constant. That is F1 over E1 is equals to F2 over E2, which is equals to K constant. Meaning it can also be equals to F3 over E3, as in like that. So that is the meaning of F over E is constant. Now that is the formula we are going to apply. So F over E is constant. So our formula now is F1 over E1 equals F2 over E2. So what is your F1? So F1 is 1.5 divided by E1 0.02 is equals to F2, that is 4, divided by E2. So we need to know the new extension, so cross multiply. So you have 1.5 e2 equals to 0.02 times 4. So that should be 0.08. Now e2 is equals to 0.08 divided by 1.5. So e2 is equals to 0.08 divided by 1.5. So that is 0.05 centimeter. So that is the new extension if you extend by 4 Newton. So that means the question will becomes, so that is our new extension, but what the question asks is the length, not the extension. So the question asks for length. So let's say I attach a 4 Newton force here. So and I know the original length is 1.5. So it's shown now that if you apply a force of 4 Newton, the extension is 0.05. So that means the extension is 0.05. So the new length of that string now is, so the answer now, so what will the length be? So the length is now 1.5, that is the original length, plus the extension, that will give us new length because the string will stretch, plus 0.05. So the new length is 1.5 plus 0.05. So that is 1.55 centimeter. So that is the answer. So the answer is correct, 1.55 centimeter. So that is the original length. So now for number 3. So number 3. If a force of 100 Newton stretches a spring by 0.1 centimeter, find the elastic constant. Now the elastic constant is a force constant. Now force constant means if I have 100 Newton per meter, it means if I stretch a certain spring by 1 meter, so I will apply 100 Newton force. So that is the meaning of 100 Newton per meter. So and it is called stiffness of a spring. So if I have 1000 Newton per meter, that means to stretch a certain spring for 1 meter, I have to apply 1000 Newton force to stretch a certain spring by 1 meter. So this string is stiff. That means I will apply a large force to strength. So that is the meaning of your force constant. So if I have this now, if a force of, so I have a string, if a force of 100 Newton stretch, so I don't know the original length of this spring, I don't know, but I know that if I apply a force of 100 Newton, this will stretch by 0.1 centimeter. So find the elastic constant. So it's easy to find. So we already know that to know the elastic constant, the formula that relates it is F is equals to Ke. So remember, K is equals to F over E. That is your force constant or elastic constant. So K is equals to 100 Newton divided by 100 Newton divided by E. That is your extension. So the extension is 0.1 centimeter. So the units here, we have to convert units because this is Newton and this is centimeter. So change centimeter to meter. So let's change that first. Change centimeter to meter. You divide by 100. So that means you are dividing this on 0.1 centimeter by 100. So convert. So 0.1 divided by 100. So that is 0.001 centimeter. So that means your force over extension now is 100 divided by 0.001 meter. Sorry, as in we have changed from centimeter to meter. So that will be 0.001 meter. So meter. So now divide this over this now. 100 divided by 0.001. So you have K is equals to 100,000 meter. Newton per meter. Remember, Newton is up, meter is down. So the unit is Newton per meter. So that means our K, this 100,000 is the same thing as 10 raised to power 5 Newton per meter. So that is your elastic constant or force constant. So the answer is correct. Now the B part. The work done in stretching the spring by 0.1 centimeter if elastic limit is not reached. The elastic limit is not reached means the spring can still retain its original position after you stretch it. So the elastic limit is not reached. If elastic limit is reached, it cannot go back to the original position. So the same spring, you stretch it by 0.1 using the same force. What is now the work done? Remember, work done is force times displacement. That's the formula for work done. If the force is constant, so this is the formula. If force is constant, so we can also use this x, displacement s like this, you can represent it as x. So that means work done can be fx, as in force times displacement. Now this is for constant force, but if the force is variable, then it will be integral of f dx. So we have done integration before, and know that f is equals to kx. Remember, I'm using e in the previous, that e is extension. If I don't use e, then I'll use x. So now this will be work done is equals to integral of, instead of writing f now, write kx ds. Now remember, the power here is 1. So to integrate, you add 1 to the power divided by the power. So work done is half ks square. So that will be the formula for work done in stretching the spring. So take note now that x can be e. So I can also say work done is half ke square, like that. So since I know my k, I can work out the work done. So the work done is equals to half times, I found k to be 10 raised to power 5. So that means k is 10 raised to power 5 times e squared, that is extension, is given like 0.1. So that is 0.1, okay, centimeter. Remember, we've changed this to meter, we got 0.001 meter. So this will be 0.001 square. Now just press your calculator. So work done is equals to half times 100,000, because 10 raised to power 5 is 100,000, times 0.001 square. So that will be 0. You have 5 zeros. 1 2 3 4 5, then 1. So now multiply everything together. So work done is 100,000 times 0.00001 divided by 2. So remember we have a, so you divide by 2, just press your calculator, or times 0.5. So you will get 0.05 joule. So unit for work done is joule, so it's also correct. Now if you don't want to use that half ks square, from there we can still get, since we know our force, we know that W is half ke square, so I can say this is also half times ke times e. Remember, e times e will be e square. So what is ke? So I've told you that F is equals to ke. So if F is ke, so I can represent this ke as F. So that means work done is equals to half Fe. So you can also use this to find your work done. So far you know your force. So work done is half, what is our force? 100 Newton times E. No, that is the extension. So we'll convert it to meter. That is 0. That is 0.50 times 0.001. We'll convert it to meter. So that is half Fe. F times E. F is 100. E is 0.01 meter, because we'll convert. So now press your calculator. So work done equals 0.5 times 100 times 0.001. So work done is equals to 0.5 times 100 times 0.001. So that is 0.05 joule. So which is still the same result. So is either you use half ke square or half Fe, you get the same results.